Welcome to Homework Help 4.6. Here we go. I'm going to do it on here because I think it'll be easier for you to see. Here we go. So the first, how many are there? 6. Okay, the first 6, you are determining the domain and the range, and then saying whether it's discrete, continuous, or discontinuous, and then writing intervals of increasing and decreasing. Oh, or constant. Okay. So it's a whole lot that you're doing. Let me see. We'll just start with number 1. So let me do this. Excuse me, stitch. Pardon. All right. So they're all functions. They tell you that each representation, they tell you it's a function. Words. So we'll do domain and range first. Here we go. Domain. Domain is all about your x values. So you're looking from left to right. So my furthest left point is -5. So my domain is going to be bracket -5, and my furthest right point, that's right here, that is +5. So my domain is -5 to 5. Oops, sorry. Why is it always so hard to just line them up? Fine. -5 to 5. That's my domain. My range, so range, you're looking low to high. So it's all about the y values. Range is all about the y values, right, Stitch? Yeah, it's all about the y values. So, goodness. My lowest point on this graph is 0. My graph does not go below y = 0. So my range, bracket, 0. And you're using brackets because they are on the graph. You use parentheses for holes when you're approaching numbers for infinity, okay? But if it's actually on the graph, use a bracket. And then my highest point. So we're going low to high. Just draw a line, straight line. Okay, so you're going low to high. So my highest point is right here, and that is at 10. Oh, so my range is 0 to 10. Bracket. Okay? What else do we have to do? Then indicate, oh, so a discrete graph, I don't think any of these are discrete. Let me look real quick. Okay, no. None of these are discrete. Discrete is when you just have points with no lines connecting them. You just have points. So none of these are discrete. This one is actually continuous. Continuous means, let me just grab my, no, I guess this is fine. Continuous means there are no breaks in the graph. Okay, it's just one continuous line. I can draw this without ever picking up my pencil. It's one continuous line. So we are continuous, and then increasing, decreasing, and constant. Okay, and so this one is always increasing. So it's always increasing. So you could write that as it's increasing from your domain. When you're talking about intervals of increasing, decreasing, you're talking about the x values. So it's increasing from x = -5 to 5. So that's where our graph ends. There are no arrows on it. So it's always increasing. So it's increasing the whole domain from -5 to 5. Number 2 is a little tricky, so I'm going to do number 2 with you too, as well. I'm going to do number 2 as well. So let's start with our domain. Okay. So domain is farthest left value. It's my value. So we're looking at x values. Farthest left. That would be negative 10. Negative 10. Ooh. Okay, let's go through our graph. Actually, I'm gonna steal this line. Okay. So our farthest left value is negative 10. And then I just want to make sure that my line is always hitting at least one point on the graph. So we're hitting something, we're good, we're good, we're good, we're good, we're good. They try and trick you here. I think that's what they're trying to do. Because there's a hole there, right? At x equals 0, there's a hole. Let me let go. There's a hole there, but this one is filled in. So it's taken care of. So x equals 0. Even though there's a hole, it's filled in here. It's filled in right here. So x is still good, so we're still good with our domain. Let me grab my line again. That didn't work. Let me grab my line again. There we go. Okay, we're going, we're going. We always hit a point. So same thing here. There's a hole there, but this is x equals, what is this, 3? Yeah, x equals 3. So we're good. It's filled in here. So x equals 3. So this graph, every x value between negative 10 and positive 10 has a y value. So your domain is negative 10 every time. Y. There we go. Negative 10 to 10. That's your domain. The range, now you're looking low to high. Low to high. Let me grab this line. So what's your lowest point? Right there. And that is negative 4. So your range, bracket, negative 4. Oops. Bracket, negative 4. And then, let's see if we keep going up. Make sure you're always hitting a point on the graph with your line. So make sure my blue line is always hitting a point on the graph. Yes, yes. Oh, it's not quite long enough. It would hit there and there, so we're still good. Once again, there's a hole right there, but it's hitting over here. So as long as it's hitting your graph in one spot, you're good. You're covered. Keep going. It's there. Okay. But then our highest point is a hole. Our highest point is a hole at 7. Yeah, our hole is the highest point at y equals 7. That's the highest point on a graph. It doesn't hit the graph anywhere else. It only hits it on the hole. It only hits it on the hole. So that means we are approaching 7, but we never actually get there. There's a hole. I don't know if this helps. Oh, too high. But if it's a hole, think of it as you don't actually want to fall on the hole, right? You're just approaching it. You get really, really close, but you never actually fall in the hole. It's just going to be a little up. Negative 4 to 7. That's your range. Let me make sure I'm right. Okay. Then, what do we do? Oh, is this graph continuous? Can you draw this graph without ever picking up your pencil? No. There are breaks in the graph. So this is discontinuous. Discrete would just be points. There would not be any lines drawn in at all. So this is discontinuous. All right, and then, oh, increasing and decreasing. Let's do increasing first. So where on this, well, no, decreasing is going to come first. So we'll do decreasing first. Decreasing. Just because I like looking left to right. So where on this graph are we decreasing? So where are we going down? Well, from negative 10, and remember, you're looking at the x values. So from where x equals negative 10, we go down, we're decreasing until x equals 0. Y equals negative 4, but we don't care. When you're talking about intervals of increasing and decreasing, you want the x values. So we are decreasing from x equals negative 10 all the way to x equals 0. Okay. I'm double checking with the book because they got a couple of these wrong, so I just have to remember to go correct them before I post answers. Okay. Anyways, where else on this graph are we decreasing? So from left to right, where else are we decreasing? So we are decreasing here. The next thing you will see is this guy. Well, this guy is going up. This guy is increasing. So we'll get to him in a second, but then we're decreasing from here to here. This is also decreasing. So that's x equals 3 to 10. So we're decreasing from 3 to 10. Okay. Those are intervals of decreasing. Intervals of increasing. Oops. So we are increasing on this guy. But there's a hole. So you're going to write this one with parentheses. We are increasing from x is 0, 0 to 3. Okay, there are holes there. So that's why I'm using parentheses. There are holes there, so that's why I'm using parentheses. Hopefully that's what they got. It is. That's number 2. Number 3, you can try on your own. Number 4. I might do part of number 4. Okay, the only thing I want to say about number 4 is this. So you should be able to figure out your domain. So look left to right. So highest, farthest left point to farthest right point. Your range, low to high. So what's your lowest point? It's right here. And your highest point is right here. Right here. Right there. It's at 4. Your highest point is at 4. Okay. What do I want? Now I forgot what I want to talk about. Oh, increasing and decreasing. So, see, we are decreasing. And here's where it gets a little wonky, because you can't totally tell where it is. Because for me, it looks like it changes, it like stops. So it goes flat for a second, like right in between. But I think what's your book say? What number are we on for? -11 to -7. So it says -7. 10, 9, 8, 7. So it says right here. So it says that it's decreasing from -11 to -7. But I think it's kind of, well, I guess that's about right. If you also said this point, that would be okay. I would take it. Just so you're decreasing from negative x equals x equals -11 to x equals -7. And then here's what you can choose, because it doesn't matter. You can either put a bracket there, or you can do a parenthesis. Okay, so I'm going to do, let's just say I do a bracket. So it's decreasing. No, I'm going to do a parenthesis. I'm going to do a parenthesis. So it's decreasing from x equals -11 to x equals -7. And then I'm going to say, for an increasing interval, it's increasing from -7 to whenever it stops increasing. When is that? So we're increasing, I guess, until 4. Is that? Let's see if I agree with the book. I don't think I do. Oh, they say 3. That's fine. 3 or 4 is fine. Or you can say 3.5. Anyway, so we're increasing until you hit 3 or until you hit 4, whichever one you say is fine with me. You get the idea. I mean, I'll do 3. That way I match the book. Okay, so notice how there's a parenthesis here, so you have to have a bracket here. If you want to switch it, you can, and have the bracket here and the parenthesis here. And then I'll keep my letter going. Do another parenthesis. And so then when it hits 3, then we start decreasing again. So we're also decreasing from 3 to decreasing all the way to 9. Okay, so there, I did the decreasing and increasing intervals for you for number 4. Number 5, I'm going to let you do. Number 6, I'm going to let you do those. Okay, that's all I'm going to do on those. Number 7. Here we go. So the speed limit for driving in a school zone is 20 miles per hour. That seems so slow if you're riding in a car, but have you ever wondered how quickly you could come to a complete stop going that speed? Even if you had super quick reflexes, it would take you over 13 feet. The speed of a vehicle, s, okay, and the stopping distance are related by the function s of d equals the square root of 30d. Okay, so they give you the function, and they tell you what it means. Oh, too much. Nope, okay, we'll do one thing at a time. There we go. Okay, that's your important information. So it says fill in the table, round to the nearest whole number, then graph s of d and answer the questions. So round to the nearest whole number. So what you're going to do is you're going to substitute these values in for d and you're going to solve. So I'll go ahead and do the first one for you. I'm not going to do all of these. So I would substitute, let's see, I'm just going to say s because I don't want to write, fine, s of d equals, I'm going to substitute 25 in. So let's do 25 equals the square root, and here comes the reason why I didn't want to do it on the computer. Okay, the square root I knew there was a reason. There we go. The square root of 30 times 25. So that will give you 30 times 25. You can use a calculator. And then you're going to find the square root of that. So let me do it. 30 times 25 is 750. And then, let's see. So the square root of 750. The square root of 750. Okay. So the square root of 750 is 27.386. Oh, 0.386. So it says to round to the nearest whole number. So 27.3, you would round down to 27. That's why it says round to the nearest whole number, because you're going to get decimals, I think, on all of these. Okay. So then you would substitute 50 in for D, and then 30 times 50, and then take the square root of it, and you should get, I don't know, 39. Okay, so finish filling out the table, and then you would go ahead and graph it. They labeled it for you. They even put they even labeled the axes and they put the scale, that's the word. They put the scale on there for you, okay? So your stopping distance is down here. So you can just plot the points that you get in your table. So I'm going to let you graph it. Okay. Number 8. So you're trying to figure out if this driver is lying or not. He says he was going under 60 miles per hour, but the tire marks show a pattern for 150 feet. So this is your stopping distance. That's your stopping distance. So if you know the distance, you're going to substitute that in and figure out what you get for the speed. So if his stopping distance was 150, what was his speed? So was this guy telling the truth or not? Number 9, use your answers in problem 8 to make a graph of stopping distance as a function of speed. So number 9 means they want you to make the inverse. So once again, wow, that was nice of them. They did the graph for you. So now speed is your x and stopping distance is your y. So you're just gonna, everything you have in the table, you're just gonna flip it and graph that. All right. Last part of the homework. Solve each equation for the indicated variable. This comes in handy because when you're finding inverse equations, you have to solve for different variables, right? You have to like switch x and y and then solve. So that's kind of how this is related. Okay, 1 second. I have to decide which one of these I want to do. I'm going to pause you. Okay, so I'm going to do 11, 13, and 15. I'm going to do them on a Word document because it's a little bit easier. 11, 13, and 15. Here we go. So this is number 11. So it says solve for r. So you want to get r by itself. Well, right now you have c equals 2 pi r. Hopefully that sounds familiar. That is the formula for the circumference of a circle. But anyways, you don't really need to know that right now. So what you're going to do is solve for r. This is 2 times pi times r. So to get r by itself, I'm going to, let's do a different color, sure. Divide by 2. Let's see if pi is in here. Yeah, 2 pi. I'm going to divide by 2 pi. Okay. So on this side, it'll cancel out. So I will get r, come on, r equals c, third equation, fraction. You get c over 2. Wait for it, pi. So I just divided by 2 pi. Because I was multiplying 2 pi times r, so to get r by itself, I divided by 2 pi. All right. So here we go, solve for h. Pi r squared h. So similar idea, I'm multiplying h by pi r squared. So I'm going to get h by itself, I'm going to divide by that. So I get insert equation v over pi r squared. Oh, too far. Where'd you go? What the heck? Okay, fine. Oh, that's why insert symbol. Just do that way. Pi r squared. H equals v over pi r squared. Okay. This last one, you're going to solve for e. So v equals e cubed. So solve for e. What do you think you're going to do? It's e raised to the third power. To get rid of that, how do you undo raising something to the third power? How do you undo that? What makes it cancel out? Okay, if it was e squared, to cancel that out, you would take the square root of both sides. So to cancel out e cubed, you're going to take the cubed root of both sides. Take the cubed root of both sides. Okay? So you're going to get, that'll cancel out e to the third power, e cubed. The cubed root of e cubed is just e. So we canceled that out. So we get e is equal to the cubed root of v. The cubed root of v. Okay. So there you go. I will leave you on your own to do the rest. Good luck. Good luck.